Today, we take a relaxing journey through the vast expanse of our solar system as we explore each of the fascinating planets that call it home. From scorching hot Mercury to the distant and mysterious Neptune, let's embark on an epic adventure together. To start our journey, we need to understand the basics. Our solar system consists of a central star, the Sun, and the celestial bodies that orbit it. There are 8 planets in our solar system, divided into 2 categories: terrestrial and gas giants. Our first stop is Mercury, the closest planet to the Sun. It's a scorching hot world with extreme temperature variations. During the day, the surface can reach up to 800 degrees Fahrenheit, but due to the lack of a significant atmosphere, temperatures drop as low as 290 degrees Fahrenheit below zero. In Celsius, the temperature range is 430 degrees and negative 180 degrees respectively. Despite its harsh conditions, scientists have sent missions to explore its secrets. NASA's Messenger spacecraft orbited Mercury for more than 4 years. During the mission, the spacecraft found evidence of water ice at Mercury's poles. This is possible because the tilt of Mercury's rotational axis is almost zero, creating areas on the surface that never see the sunlight. Next up is Venus, often called Earth's sister planet due to its similar size and composition. However, Venus is a hellish world with a thick, toxic atmosphere and surface temperatures that can melt lead. It's a runaway greenhouse effect that causes the extreme heat on Venus, making it the hottest planet in our solar system. Venus rotates so slowly on its axis that one day takes about 243 Earth days. This is longer than the time it takes Venus to orbit around the Sun, making a Venusian day longer than its own year. Venus rotates on its axis the opposite direction of most other planets. This means if you were standing on Venus's surface, the sun would rise in the west and set in the east. Venus has been explored by various space agencies, including NASA with Mariner 2 and Magellan, for example. And in 2021, NASA's Parker Solar Probe made multiple flybys of Venus, capturing visible light images of the surface from space. In the 1960s and 70s, the Soviet Union successfully sent probes to the surface of Venus. The atmosphere is much denser than that of Earth. Roughly, the pressure found 900 meters or 3,000 feet underwater on Earth. These extreme conditions destroy the probes relatively quickly. It's a very difficult place to explore. Now let's turn our attention to the third rock from the Sun, our very own planet Earth. It's a world we're intimately familiar with, but there's always more to discover and appreciate. Earth is a planet of incredible diversity and complexity, and its unique characteristics make it a one-of-a-kind world. Here are some remarkable facts about our home planet. Earth is the only known planet to support a wide variety of life forms, from microscopic organisms to the complex ecosystems we see today. The diversity of life on Earth is staggering. Approximately 71% of Earth's surface is covered in water, primarily in the form of oceans. These oceans play a critical role in regulating our planet's climate and are home to an astonishing array of marine life. Earth's atmosphere is a mixture of gases, primarily nitrogen and oxygen. This unique combination is essential for supporting life as we know it. Our atmosphere also serves as a protective shield, absorbing harmful solar radiation and providing the air we breathe. Earth's water is in a constant state of movement, cycling through the atmosphere, oceans, rivers, and back again. This water cycle sustains life and shapes our planet's landscape. Through processes like evaporation, condensation, and precipitation, water continuously circulates, replenishing our freshwater resources. Earth's outer shell, or lithosphere, is divided into tectonic plates. These plates are in constant motion, which has led to the shifting of continents over millions of years. The theory of plate tectonics helps explain earthquakes, volcanoes, and the formation of mountain ranges. The movement of tectonic plates has had a profound impact on Earth's geological history and continues to shape the planet's surface. Earth's biosphere is the region of the planet where life exists. It includes everything from the deepest ocean trenches to the highest mountain peaks, and even extends into the atmosphere. Life on Earth has adapted to a wide range of environments. From the depths of the ocean to the deserts, rainforests, and polar regions, the biosphere is teeming with an array of species, each playing a unique role in the ecosystem. Our planet has a magnetic field that extends into space and helps protect Earth from harmful solar radiation and charged particles. It's generated by the movement of molten iron in the planet's core. This magnetic field is crucial for maintaining the conditions that make life possible on Earth. As we wrap up our exploration of Earth, it's clear that our planet is a wondrous and dynamic place, filled with life, natural beauty, and complex systems that we are only beginning to understand. It's a reminder of the importance of preserving and caring for our home. Next up, we have Mars, the red planet, which has always captured our imagination. Let's delve deeper into this intriguing world. Mars has a thin atmosphere. It's only about 1% as dense as Earth's, and it's mainly composed of carbon dioxide with traces of nitrogen and argon. It's unable to support human life. Olympus Mons is the largest volcano in the solar system, standing nearly 22 kilometers or 13.6 miles high, which is about 3 times the height of Mount Everest. And Mars has significant deposits of water ice, primarily at its polar ice caps. Scientists are interested in these ice deposits as potential resources for future human missions to Mars. Mars has been the target of numerous robotic missions, including the famous Mars rovers, such as Curiosity and Perseverance, which have made groundbreaking discoveries, including evidence of past liquid water on the planet's surface. As we wrap up our exploration of Mars, we've barely scratched the surface of this captivating world. With its towering volcanoes, vast canyons, and the promise of future human exploration, Mars continues to be a source of inspiration and scientific discovery. As we move on to the gas giants, our first stop is Jupiter, the largest planet in our solar system. With its swirling clouds and iconic Great Red Spot, Jupiter is a mesmerizing world. It also has a diverse family of moons, including the intriguing Europa. Jupiter is over 11 times wider than Earth and has a mass more than twice that of all of the other planets in our solar system combined. It's so massive that it could have become a star if it had gathered just a bit more material during its formation. One of the most iconic features in Jupiter is the Great Red Spot, a massive storm that has been raging for centuries. This colossal tempest is larger than Earth itself. Jupiter boasts an extensive family of moons with over 80 natural satellites. The 4 largest moons, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons and are some of the most intriguing bodies in the solar system. Io, for instance, is a moon of Jupiter that's renowned for its intense volcanic activity, with plumes of lava reaching into space. Europa, on the other hand, has an icy surface that conceals a subsurface ocean, raising the possibility of life beyond Earth. Ganymede is the largest moon in the solar system and has its own magnetic field. This is unique among moons. And Callisto, with its heavily cratered surface, is a testament to the violent history of our solar system. Jupiter also has a faint ring system, although it's not as prominent as Saturn's stunning rings. To unlock the secrets of Jupiter, NASA's Juno spacecraft has been in orbit around the planet since 2016, studying its composition, magnetic field, and polar regions. The Juno Cam has provided breathtaking images of Jupiter, allowing us to explore its majestic clouds and dynamic atmosphere. Jupiter's magnetosphere is the largest of any planet in our solar system, protecting it from solar winds and cosmic radiation. As we conclude our exploration of Jupiter, it's clear that this gas giant is a world of superlatives. From its sheer size to its remarkable moons and stormy features, it continues to be a source of wonder and scientific discovery. Our next destination is Saturn, the ringed wonder of our solar system. Saturn's mesmerizing rings and unique characteristics make it a truly captivating subject for exploration. It's a planet of many mysteries and incredible features. Here are some remarkable facts about this gas giant that make it stand out among the planets. Saturn's rings are its most iconic feature. These dazzling rings are composed of countless particles of ice and rock, ranging in size from tiny grains to several meters in diameter. The rings are divided into multiple distinct rings with gaps, and they stretch out over thousands of kilometers. The origin of Saturn's rings is still a subject of study, but they provide a breathtaking spectacle that has fascinated astronomers and the public for centuries. NASA's Cassini spacecraft, in collaboration with the European Space Agency and the Italian Space Agency, spent over a decade studying Saturn and its moons. It provided us with a wealth of data about Saturn's atmosphere, rings, and moons. The Cassini mission ended in 2017 with a dramatic plunge into Saturn's atmosphere, a deliberate maneuver to avoid contaminating Saturn's moons with earthly microbes. Saturn's North Pole is home to a mesmerizing hexagonal-shaped storm, which was first discovered by the Voyager missions in the 1980s. This atmospheric phenomenon is unlike anything found on any other planet in our solar system. The exact cause of this hexagon remains a subject of ongoing scientific investigation, adding to the enigmatic nature of Saturn. Saturn has a remarkable assortment of moons, with over 80 known natural satellites. One of the most intriguing is Titan, the second largest moon in the solar system and the only one with a substantial atmosphere. Titan's thick atmosphere and Earth-like geology have made it a target for future exploration. Saturn is known for its relatively fast rotation, completing one full rotation on its axis in about 10.7 hours. This rapid rotation flattens the planet slightly at the poles and bulges at the equator. The fast rotation of Saturn contributes to its unique appearance and dynamic weather patterns. Like Jupiter, Saturn is a gas giant composed primarily of hydrogen and helium. Its lack of a solid surface means that you couldn't stand on Saturn, as you would fall right through its thick atmosphere. The study of Saturn's interior and composition continues to be a focus of planetary science, shedding light on the formation of gas giants in our solar system. Let's drift to another ice giant in our solar system, Uranus. Its peculiar characteristics and distant location make Uranus a fascinating subject for meditative exploration. Uranus is often overlooked compared to its more famous planetary neighbors, but it has its own set of intriguing facts and mysteries. Here are some remarkable details about this enigmatic ice giant. Uranus has a unique feature that sets it apart from other planets in our solar system. It's tilted on its side, with an axial tilt of approximately 98 degrees. This extreme tilt means that Uranus essentially rolls along its orbital path. The exact reason for this unusual tilt remains a subject of scientific study, but it leads to extreme seasonal variations on the planet. Like Neptune, Uranus is classified as an ice giant due to its composition, which includes water, ammonia, and methane in its atmosphere. This hot, dense fluid of materials makes up 80% or more of the planet's mass. At the small, rocky core, temperatures reach up to 9,000 degrees Fahrenheit, or almost 5,000 degrees Celsius. Uranus has a set of faint rings, which were discovered in 1977. These rings are composed of small particles and are less prominent than those of Saturn. Uranus also has a system of at least 27 moons, including Titania, Oberon, and Miranda. These moons and rings provide additional opportunities for exploration and study. Our primary source of knowledge about Uranus comes from NASA's Voyager 2 spacecraft, which flew by the planet in 1986. The spacecraft captured valuable data about Uranus's atmosphere, rings, and moons. Voyager 2's mission to Uranus provided our best ever close-up look at this distant ice giant. As we conclude our exploration of Uranus, it's evident that this ice giant holds a unique place in our solar system with its extreme axial tilt, mysterious interior, and while it may be less known than some of its neighbors, Uranus continues to be a source of interest and curiosity. Our cosmic voyage now ends at Neptune, the enigmatic ice giant lurking on the outskirts of our solar system. Neptune is the furthest major planet from the Sun. It's more than 30 times as far from the Sun as Earth. But Neptune is far from ordinary. Its distinct, deep blue color comes from the presence of methane in its atmosphere. Methane molecules in the upper atmosphere scatter sunlight in a way that gives the planet its striking hue. The composition of Neptune's atmosphere, including methane and other gases, contributes to its unique appearance. Neptune is known for its powerful and persistent storms, including the most famous one, the Great Dark Spot. These storms are driven by intense winds that can reach speeds of up to 1,300 miles per hour, or 2,100 kilometers per hour. The study of Neptune's dynamic weather patterns provides insights into the behavior of the atmosphere under extreme conditions. Although the Great Dark Spot, discovered by the Voyager 2 spacecraft in 1989, has since dissipated, Neptune continues to exhibit dark spots and other atmospheric features, showcasing its ever-changing nature. These features are a testament to the planet's active and dynamic atmosphere. Neptune possesses a faint ring system and a diverse moon system. It has 14 known moons, and since Neptune was named for the Roman god of the sea, its moons are named for lesser sea gods and nymphs in Greek mythology. Triton is one of the most peculiar in the solar system. It orbits the planet in a retrograde direction, suggesting that it was likely captured by Neptune's gravity rather than forming alongside the planet. Triton is geologically active, with cryovolcanoes that spew icy material into space, creating fascinating surface features. Triton is Neptune's largest moon, but Proteus is one of the solar system's largest irregularly shaped moons. Neptune has at least 5 main rings that are thought to be relatively young and short-lived. The ring system also features clumps of dust called arcs. The laws of motion predict that these arcs would spread out rather than stay clumped together. We still have a lot to learn and explore. Neptune is not only the coldest planet in our solar system, but also one of the darkest. Its dimly lit environment receives just a fraction of the sunlight that reaches Earth. The extreme conditions on Neptune's surface, including frigid temperatures and limited sunlight, make it an inhospitable world. As we wrap up our exploration of Neptune, it's clear that this distinct ice giant is a world of mysteries and extremes. From its deep blue atmosphere and fierce storms to its peculiar moon system and dark, cold environment. The quest to understand Neptune's secrets continues to inspire astronomers and space enthusiasts. If you enjoyed this video, like, subscribe, and hit the notification bell to stay updated on our future adventures. Until next time, unwind.